What if I tell you that this model was created from multiple photos taken at various angles? You can get a Tallinn city model, a cathedral building in Florence, or Paris Eiffel Tower. What is even more cool, you can work with them now in 3ds Max using a Vray renderer. Let me explain. These models are done using a technique called 3D Gaussian Splatting. Now, how does it work? So first, you need to capture a subject from multiple angles using photos or video frames. With Gaussian Splatting, the better quality footage you get, the better models you will receive. It's important to avoid motion blur and shallow depth of field effects. Then the images are analyzed to figure out the camera angles and build an initial 3D point cloud of the scene. This process is called structure from motion. Next, each point in the cloud gets turned into a Gaussian splat, which is more than just a point. It's an ellipsoid with its own unique properties like position, color, size, and transparency. When all the splats are combined, they blend smoothly to recreate the original scene with amazing detail. Thanks to the optimization techniques used during the process, the models are not only easier and faster to get, but also are more efficient to work within the 3D software. This simply means that less storage and computational power are needed, while we get highly photorealistic results. In comparison to traditional photogrammetry, splatting involves training a model over thousands of interactions per scene, and as a result, it is generally better at recreating scenes containing thin geometry, reflective surfaces, and other traditionally difficult subjects. There are a couple of places where you can create and get the models. I'll be using Polycam. To make our search faster, I choose Splat type. If you want to download the model in the PLY format, you need a Pro subscription. You can see the community tries creating models of various things: interior, exteriors, furniture, small assets, people, and more. Let's do something that we could potentially use in Arvis. Here we go, the model of urban city space. We can download this one. We need to export the model to a point cloud using Splat PLY format. Now, in 3ds Max, in the Create tab, choose Vray and you find the VrayGaussian geometry object. From here, we need to upload the file, and that's it to have it in the software. Here we go. This cloud of points is our model. We have some options here we can adjust. I noticed that I need to flip the axis every time I import the Polycam model. You can choose if you want the bounding box to be on or off. This option is off by default. When it's on, we can click directly on the point cloud in the viewport to select the splat. It's handy to select again. Viewport primitives determine the maximum number of primitives, so these points, that are displayed in the viewport. It might be handy when your computer is laggy to keep this value down, but I didn't change it at all for all the time I was testing it. Let me start interactive rendering so we can see how it looks. So you can see that even though I don't have any environment map in the scene, nor the sun, I can see the model. It's because it's a self-illuminated model, so only the model is visible, the environment is black. However, it doesn't look good on the render. Something is off. You can see a third of the pixels. It's a scale. Fortunately, we can easily adjust it. I didn't change the units in my 3ds Max, so I have millimeters set up. So I need to scale a lot. Let's see how it looks now on the render. Now it looks good. You can notice that the further from the center, the less details and blurry the render gets. It's because the model has less information. But close to the center, I need to say it looks very good from this perspective. Anyway, let's check the scale. We can use a Chaos Cosmos to look for a car. As there is many vehicles in the model, it will be easy to compare. Let's move it somewhere where the cars are. Here we go. We can see the car. The scale is still off. I would say that the car is around 2.5 bigger than those on the model. I will change the scale. Here we go. It looks more or less good. Now you can notice that the car is dark. When using Gaussian splats, you need to understand that other objects in the scene needs normal light, but this light needs to match the one on the Gaussian splat. Otherwise, it will look fake. So we are quite defined by this. In this situation, we have a strong high sun from here. So we have to set up something similar in our case. I would definitely add the very sky too. Try to be as precise as possible to get realistic effect. You can see that the environment doesn't affect the Gaussian geometry, but it works with the car. It's overexposed, but I don't worry about it as I will set up the camera so we can adjust it from there. I would actually add one more, larger model to the scene, perhaps a tree, so we can see the lighting better in this scene. Okay, so we can see the objects are not overexposed anymore. If you still need to adjust it, you can do it, for example, by changing the exposure value in the camera settings. The higher the value, the darker the result will be. Something like that works well. There is another issue though. We don't have shadows from the objects. It's because the Gaussian splats are treated as self-illuminated objects in Vray, and that's why they can't receive shadows from other objects directly. But there is a workaround. Instead, we can use shadow catcher dummy geometry that covers the place where the shadows should be. I would use the Vray plane to show you how it works, but to be precise, we'd have to model the geometry where the shadows should be. It's an infinite plane, so it doesn't matter where it's placed. But I want to adjust it the closest I can to the model and the objects I have. If you want the shadows, the object needs to be placed on the plane. The same for the tree. Now we can try to adjust them all together. So we have the shadows, but we also can see the plane rendered. We can use the shadow catcher. This way, the plane will become a matte object, which will not be directly visible, but it will show the received shadows. Here we go. It looks like the shadows are on the model. We would have to adjust its position to the model, but it works. Now I use the building model to show you other options you can use with Gaussian geometry. The affect camera specifies if the Gaussian splat is visible to camera rays. If you want it to be visible on render, it should be on. If the affect shadows option is on, we can see the shadows from the Gaussian splats on the 3D model. Affect reflections option specifies if the Gaussian splat is rendered in reflections, while the affect refractions if the Gaussian geometry is rendered in refractions. Finally, the Affect Matte Surfaces option computes Gaussian splats behind matte objects as part of the background. We can also adjust the color space of the Gaussian splats data. We can also specify the main tint of the model. With the intensity, we can multiply the color parameter. The higher the value, the stronger the effect. With white, the models gets brighter or darker. Another thing I noticed is that, for example in this case, it is a drone footage, so it looks very well from the top. With many details, it looks realistic. But when I go down, you can see that there is not as much details and it doesn't look as good. So I think it could work well as a background in 3D. I wouldn't use it as an individual object within the scene, as they cannot receive the light. The effect may look fake. It's the first time when we could use Gaussian splats in Vray, so there are still some limitations. For instance, there is no render elements support, but the Chaos team plans to add CDEP, Cryptomate, and XYZ passes in the future. On the other hand, because it's a relatively new technique, there are lots of places for improvement, and I'm sure the results will become better and better. I'm happy to see what the future brings to us. Let me know what you think about this technique and if you use it in your production process. If you want to learn more about 3D topics, there are more videos to watch on my YouTube. Bye bye!